Greetings, Mr. Kolazar's class. We're going to start looking at what we're going to call VSEPR today. And VSEPR is going to be the way that we can predict the shape of molecules, because the shape of the molecules determines many of the properties of the compound. And so the shape is going to determine many of the physical and chemical properties of the molecule. And once the Lewis structure is drawn, we can get a three-dimensional shape of the object. So we're going to be trying to think of these as in three-dimensional terms. Examples: water dissolves many substances because it's polar due to its shape. Food and taste. You're going to have to check out the textbook to answer question number 6. It's going to be on page 262. That'll be an important part for you to look into on your own. What VSEPR stands for: valence, shell, electron, pair, repulsion. And it's going to be the VSEPR theory useful for predicting the shape of molecules, bonding and non-bonding pairs of electrons repel each other, placing them as far apart around the atom as possible. Lone pair of electrons take up more space than bonded pairs of electrons. And so we're going to be in the three-dimensional world looking at these. So like an example, methane, CH4, carbon is bonded to 4 hydrogen atoms. For VSEPR shape, if we were to look at this, each one covalently bonded, but as we're looking three-dimensionally, they're going to push as far away as possible, kind of making it into a pyramid-looking shape, where at each corner of the pyramid would be one of the hydrogens. We're going to call that shape in just a minute tetrahedral. So our steps for determining the molecular shape: draw the Lewis structure of the substance, determine the number of bonded atoms and lone pairs of electrons to the central atom. So the central atom is going to be the one we focus on, and who's connected to that. We're going to consult your handout to determine the shape. So you'll be getting a handout that looks at those different shapes. So our CH4, if we were to look at, it's bonded to 4 carbon, bonded to 4 hydrogen atoms. Hydrogen would be our central atom. Bonded atoms would be all of the hydrogens. So when we make that pyramid shape, we're going to know the structure to be called tetrahedral. 4 elements bonded to the central atom. So your handout looks similar to this. You're going to see the number of atoms bonded to the central atom, lone pairs to the central atom, and that's going to determine our molecular shape: linear, bent, trigonal planar, tetrahedral, trigonal pyramidal, bent, trigonal bipyramidal, and octahedral. So with tetrahedral, we have 1, 2, 3, 4 atoms bonded to the central atom and no pairs of lone electrons to the central atom. So our CH4 methane showed up to be tetrahedral. Now continuing this idea, methane, now we're going to look at ammonia, NH3. Ammonia has number of bonded atoms. We've got 1, 2, 3 bonded atoms and 1 lone pair. So when we look at this one, it's not quite the same tetrahedral. Instead, we have just our 3 bonded atoms being pushed further down by that lone pair of electrons. This one's going to be known as trigonal planar. To look at your sheet, we have 3 bonded trigonal, change that word, 3 bonded pairs and 1 unbonded pair or lone pair of electrons. Trigonal pyramidal is that name. So the trigonal pyramidal has that lone pair of electrons up there, and it actually pushes more against the bonded pairs of electrons. It takes up more space, and it pushes those ones closer together. Trigonal planar, no lone pairs of electrons, and so trigonal planar, they're closer together three-dimensionally speaking. So we're looking at these in terms of three-dimensional. So to practice this, if you go back to page 4 in your notes, is where we're at, page 4, the practice problems we've had, to look through each practice problem looking at lone pairs of electrons and bonded pairs of electrons. In this case, central atom's carbon, and we've got 4 bonded pairs of electrons to that one. In your notes, looking at that sheet, tetrahedral. For number 2, if we only have 2 atoms, it'll always be 2 points to make a line. It'll always be linear. Now, if we have 3, we've got sulfur central atom, bonded and bonded, but we have a lone pair of electrons. Looking at your page, bent is what this is going to be, where it's actually kind of a bent shape, not linear in shape. And we have some three-dimensional computer models down below. And to finish out, 4, 5, and 6, 4 and 5 both have 4 bonded atoms to the central atom. So tetrahedral, 4 bonded atoms to the central atom, tetrahedral. And our last one, central atom has 2 atoms bonded to it, and a lone pair of electrons. So in the end, that one will be also bent. So looking at that handout, looking at the number of lone pairs of electrons bonded to the central atom, and looking at the number of shared atoms, not shared atoms, bonded atoms to the central atom, will give you the shape of the atom to determine many of its chemical and physical properties. And we'll stop there for today. That again is VSEPR, shape of the molecules.